Acidity, in chemistry, just means how much hydrogen ion, H+, is in a solution. pH is a logarithmic way of measuring that, defined as minus the log base 10 of the hydrogen ion concentration. Because it's logarithmic, small pH changes mean big chemical changes. So how does carbon dioxide change ocean acidity? First, CO2 from the air dissolves into seawater at the surface. More CO2 in the atmosphere means more dissolved CO2 in the ocean. Once it's in the water, CO2 reacts with water molecules. Instead of staying inert, it enters an acid-base equilibrium called the carbonate system. Dissolved CO2 reacts with water to form carbonic acid, and that carbonic acid partially dissociates, producing hydrogen ions and bicarbonate. Every time this reaction runs to the right, it adds H+ to the water. More hydrogen ions means lower pH. That's the direct reason ocean pH drops. But the story doesn't stop there. Carbonic acid is diprotic, meaning it can lose 2 protons. Bicarbonate can further dissociate into carbonate and another hydrogen ion. At today's ocean pH, most carbon is bicarbonate, with smaller amounts of carbonate and dissolved CO2. The exact balance depends on hydrogen ion concentration. When extra CO2 enters the system, hydrogen ion concentration increases. That shift pushes another key reaction. Hydrogen ions combine with carbonate ions to form more bicarbonate. In plain terms, added CO2 doesn't just increase acidity, it actively removes carbonate ions from seawater. This matters because pH changes that look small are chemically large. A drop from pH 8.2 to 8.1 represents about a 26% increase in hydrogen ion concentration. The ocean is still alkaline, but it is significantly more acidic than it used to be. The ocean doesn't crash to low pH because it's buffered. Total alkalinity stays nearly constant, while dissolved inorganic carbon increases as CO2 is absorbed. That combination forces the equilibrium toward higher hydrogen ions and lower carbonate. Finally, carbonate loss affects calcium carbonate stability. Calcium and carbonate form shells and skeletons as solid CaCO3. As carbonate concentration drops, the saturation state decreases, making shell formation harder and dissolution more likely. So the core chemistry is simple and unavoidable. CO2 dissolves, forms carbonic acid, increases hydrogen ions, lowers pH, and converts carbonate into bicarbonate. Ocean acidification is not about making the ocean acidic like vinegar. It's about shifting equilibria in a way that quietly but profoundly changes seawater chemistry.